Welcome back to another online lecture provided by me, your teacher, Mr. Cunningham. Today we're going to talk about a special right triangle. Now, it's not special because, like, everybody loves it. It's special because it's all over the place. And it's so common to see these particular kind of triangles both in the quote-unquote real world and in math problems that it's probably best just to know the ratios instead of having to use the Pythagorean theorem every single time. So what we're doing here essentially is we are going to come up with a shortcut for these 45, 45, 90 triangles. Now, you should recognize this as one of the large wooden triangles from my classroom. It is in fact demonstrating the 45, 45, 90 triangle theorem. So let's start with a 45, 45, 90 triangle. Okay? This angle is 45 degrees. This angle is 45 degrees. That's a 5, not a 6. Okay? So we've got this 45, 45, 90 triangle. Well, what do we know about this 45, 45, 90 triangle? If this side is, I don't know, a 7, well, how much is this side? Now, you should be able to tell pretty quickly that this side is also 7. How do I know that? Well, this 45, 45, 90 triangle, if I was to extend it out, well, that's half a square, right? A 45, 45, 90 triangle is half of a square. If you take a square and cut it down the diagonal, you get this 45, 45, 90 triangle. And since it's half a square, well, we know that all sides of a square are equal. So this side and this side must be congruent. So if this bottom leg is 7, then this side leg is also 7. If this bottom leg is 12, this side leg is also 12. If this bottom leg is 3x squared, then the side leg is 3x squared. Thinking proportionally, in both directions, you're multiplying by 1. Remember, we're still talking proportions. We are talking about similar triangles. We are going to be talking about proportions, and that means multiplication. But if you want to not change something, you can multiply it by 1. The scale factor between the two legs of this triangle, no matter what the legs actually are, is 1. So that's already pretty useful, right? If I've got a 45, 45, 90 triangle, once you know what one leg is, you automatically know what the other leg is, nice and quick. But what about the hypotenuse? Well, for that, we can use the Pythagorean theorem. If this bottom leg is, let's say, A, then this side leg is also A. So let's run that through the Pythagorean theorem and figure out what our hypotenuse is. You get capital A squared plus, now normally we would put B squared here, but they're both the same, so it's A squared again. And that's going to equal C squared. So this is a good reminder of the Pythagorean theorem that we learned last time. Leg squared plus leg squared equals hypotenuse squared. Well, A squared plus A squared is 2A squared. And then we want to square root both sides. And we get C equals the square root of 2A squared. Well, I know what the square root of a squared is, right? The square root of a squared is a. So the only thing left under the square root is this 2. Now, where did that 2 come from? Take a second and see if you can work out, where did this 2 come from? What is that in reference to? Why is it there? Take a second, think it over. Well, if you follow the 2 back, where it came from was the fact that there are 2 a squareds, as in there are 2 legs, that you're adding together. And because they're the same, you're essentially just doubling the leg. So the end result is that the hypotenuse is the leg times the square root of 2. And that's going to be true for every 45, 45, 90 triangle forever. Remember, if I erase something before you're ready, you can always go back and pause. So a few things that we've learned here. We learned that all 45, 45, 90 triangles are similar. They all have the same proportions. This is super useful because it means that we can now apply what we know to any 45, 45, 90 degree triangle in the world, and we'll do that in a moment. We also know that the legs of the 45, 45, 90 triangle are congruent. And then finally, we know that to find the hypotenuse, we take the leg and multiply by the square root of 2. So let's do a couple of examples of this and make sure everyone understands what's going on. Okay? So I'm going to go down here and I'm going to make another right triangle. Here's another 45, 45, 90 triangle, and I'm going to reorient it just to make sure that we don't get stuck in one position. There's the 90-degree angle. Okay? So let's say that this leg here is 12. Pause the video very quickly. Oh, you got it already? Fantastic. For those folks who aren't quite so quick as to be able to see it instantly, please pause the video really fast. Take a couple of minutes. See if you can tell me what is this side and what is this side. Use the notes that you took up here. See if you can find me those two sides. Ready, set, go. Did you get it? Again, remember, the two legs equal each other, and to find the hypotenuse, you take the leg and you multiply it by the square root of 2. Let's do another one. Ready, set, go. See, again, once you have the pattern down, it gets quick. You don't have to worry about using the Pythagorean theorem every time. Once you know the pattern, or at least have the pattern in front of you, you can just fill it in without having to do any extra work. And I figure you, like me, probably really appreciate not having to do work. Here's a tricky one. What if I call this 2 times the square root of 3? Okay? Well, the other side, the other leg, should be 2 times the square root of 3, right? And the hypotenuse is the leg, 2 times the square root of 3, times the square root of 2, just like before. Every single time you go from the leg to the hypotenuse, you are multiplying by the square root of 2. But only for 45, 45, 90 triangles. Okay, so how do I deal with this nonsense? Here's the easiest way to remember it for me. Whole numbers multiply with whole numbers, square roots multiply with square roots. So we've got this whole number 2, but it's not being multiplied with anything, so it just stays 2. The square root of 3 times the square root of 2 is the square root of 6. And that's our answer. Okay, let's do one more example. And I'm actually going to reorient this again, just to make sure that we don't get stuck in one mindset here. Let's make it sort of weirdly tilted like that. Okay? Now we're going to do something slightly different. What if I had a hypotenuse that's 5, and I want to find the legs? Okay? Take a look at the notes that you've been taking. That's these up here. This isn't directly covered in the notes that we took, but I think you can figure it out. We know that if you have the leg, to get to the hypotenuse, you multiply by the square root of 2 if you're going that way. So if you're going the other way, well, what's the opposite of multiplication? We talked about this in class all the time. If it's multiplication in one direction, then in the other direction, it's division. So the two legs would be 5 divided by the square root of 2. And because it is isosceles, 5 divided by the square root of 2. So let's add that to our list of 45, 45, 90 facts. To find a leg of a 45, 45, 90 triangle, you can take the hypotenuse and divide it by the square root of 2. So I'm going to clean this up a little bit. This is what should absolutely be in your notes about this topic. So that's everything I've got for you on 45, 45, 90 triangles for the time being. You definitely want to have this down in your notes because it can make a very difficult problem very easy. Essentially, at this point, if you know you have a 45, 45, 90 triangle, all you need is one of the 3 sides, and you can pretty much instantaneously find the other 2 sides without having to do a whole lot of actual math.